Okay, we're here to do some exciting geometry, and I'm totally thrown off because I can see that the thing is like crooked up here. That's going to bother me the entire video, but we're going with it. Okay, so 12.6, page 840, segment relationships in circles. This should be a pretty quick instructional video. There's only a few concepts we need to go over. So hopefully it won't be too terribly confusing. Let's go ahead and get started with the one on page 840. All right, so there's my circle. I have two chords. Remember, chord goes from one side to the other side. I have a C, E, D, B, and A, I think is what I've got there. Okay, so the rule about this, if I need to figure out lengths of sections of the chord or the entire chord in general, there's a relationship between them. And what it is it's multiplying. And what it is it's AE, which is this section, times EB, which is this section. Okay, so each half that you times the halves, and it equals the other two halves. How can I do this differently? This half times this half. Okay, so this times this equals this times this. Okay, pretty straightforward, I think. So let's look at example number 1. Find the value of x and the length of each chord. So on there, I'll use my picture even though it's a slightly different angle than theirs. They have an x. Oh, let me do it. Yeah, that's okay. An x and an 8, and then they have a 4 and a 6, like this, okay? So the rule is this times this, so 8 times x is going to equal this half times this half, even though they're not the exact same size necessarily. This portion times this portion, okay? So 6 times 4. So this times this equals this times this. So 8x equals 24, so x would be 3. Be careful to look at your instructions and make sure you know exactly what they're looking for. They say find the value of x, okay, we did that. Then find the length of each chord. So ST in our picture, I'm sorry, my letters are wrong, but one chord has the length of 3 plus 8, which is 11, and the other chord has a length of 10 because we already know the two parts of that one, okay? So make sure you read your directions to put everything down that they want you to answer. Remember, this times this equals this times this. All right, let's look at example number. We're not going to go to example 2 yet. We're just going to look at the reason on page 841, or the rule that we're going to learn on page 841. Okay, example 2 is just the same concept, just with a word problem. I think you can read through there, okay. All right, so let's look at this one. Here, theorem 12.6.2, two secants in a circle like this is what we're talking about. Okay, so for this one, the rule is the entire length, which in this picture is A to E, the entire length, AE, times the outside portion. So the entire thing times the outside portion equals this entire thing, which is CE, times, you guessed it, this little portion right here, which probably is a D. Yeah. So the rule for this one, when you have a picture that looks like this, it's this whole thing times this equals this whole thing times this. So let's look at example for this one. Example number 3. Okay, example number 3, I'll just draw it down here. It'll be a little smaller, but that way we're not confused because I have a different picture here. Okay, so it kind of looks like this. We have an R. Oh, it takes me so long to do this, sorry. S, T, P, and Q. Okay, and we have that this is 4, and this is 6, and this is 5, and this is X. Sorry, that just takes me forever to do. Okay, so remember our rule is the whole thing times the outside part, okay? So the whole thing for this guy is 10, right? 6 plus 4, 10, times the outside part, which is 4, equals the whole thing. Watch this, just be careful. The whole thing is really 5 plus X, right? And we're going to multiply it by the outside part, which is 5. I really should have written that the other way, but the whole thing is 5 plus x, and we're going to multiply it by the outside part, which is 5. Are they both 5? I just want to make sure I wrote that down correctly. No, 4. Yeah, okay, that's good. All right. So we're going to go ahead and simplify this. This is 40. 5 times 5 is 25. 5 times x is 5x. So far, so good? Subtract your 25. 25, 35, 40, is that 15? Okay, and we're going to divide, and what's x going to equal? 3. Yep, 3. Perfect. I just was looking at the wrong one. I'm like, wait a second, what happened there? I went totally off track, but we're good. So x is 3. Remember, it says find the value of the length of each secant segment. So x is 3. So they want you to find RT, which is 10. We know that already. And they also want you to find RQ, which is 5 plus 3, which is 8. Okay? So the whole thing times the outside equals the whole thing times the outside. All right, let's look at the last one, which is theorem 12.6.3. Okay, let me get this erased. Theorem 12.6.3. Can I use the same circle? Sure. Awesome. Okay, so in this one, we have a secant and a tangent. Okay, a secant and a tangent. I'm on theorem 12.6.3. Okay, so the rule for this one is the entire thing times the outside portion, just like before, which is BC. So that's nice that that part stays the same. But if this is a tangent, it equals this little outside part squared. Okay, so if you have a secant and a tangent, it's the whole thing times the outside, just like it was on the last one. But then the other side has to be this end squared. So let's see if we can find an example for this. Let's do example number 4. We'll just do it right here. Example number 4 has a tangent and a secant. Does this go through? Yep, okay. All right, and we have that this is x, and I have that this is 4, and that this is 5. Okay, so the rule is the entire thing, which is 9, times the little outside part, 4, not drawn to scale, equals this outside part squared, right? All right, so what's 9 times 4? Okay, and to get rid of a square, we square root. So the square root of 36 is plus or minus 6, right? Because plus 6 times plus 6 is 36. Negative 6 times negative 6 is 36. Okay, so it's plus or minus 6 when I square root that guy. And they want to know just the value of x, so I'm done. Okay, so the rule for this one again is the whole thing times the outside equals the outside squared, because this is a tangent, not another secant. Okay, so those are the rules for today's circles. And now you're having fun with circles. I have a question for you. How many mathematicians does it take to tie up a package? How many mathematicians does it take to tie up a package? None. You just need a cord. Goodbye.